Hello friends, welcome back to the online classroom. Today we are going to see direct coupled amplifier. In the last lecture we have seen transformer coupled amplifier and we have seen how to use it as a impedance matching or for a impedance matching purpose. And in the previous lecture we have also seen RC coupled amplifier which is used for audio amplification because it gives a very good frequency response, or you can say gain, voltage gain, or a audio range, or you can say it gives very good audio fidelity. So here we'll see the direct coupled amplifier. So in the figure you can see it is a three-stage amplifier. As you can see there are three transistors T1, T2 and T3. So it is a three-stage direct coupled amplifier, or you can also say two-stage direct coupled amplifier. So when you remove the capacitors from RC coupled amplifier, then it will be a two-stage direct coupled amplifier. So when you remove the capacitors or transformers, or you can say the coupling device from your multi-stage amplifier, see, in the direct coupled amplifier you are not using any coupling device, maybe whether it is a capacitor or a transformer. So you are not using any coupling devices. So you may ask, there should be a change in Q point or operating point, or you can say DC biasing might be get affected due to not using the coupling device. But you can say in the direct coupled amplifier the DC biasing is adjusted so that without using any capacitors or transformers or coupling devices you can get your operating point or Q point at your desired level. So the first use of direct coupled amplifier, first we'll see why direct coupled amplifier is necessary. So in the last two types of multi-stage amplifiers, that is RC coupled amplifier and transformer coupled amplifier, we have seen its frequency response, and in its frequency response it is very clear that both the types of amplifier did not amplify low frequency signals. So we cannot get amplification for low frequency signals, you can say the signals below 10 hertz frequency. So in your physical world you will be getting a signals below 10 hertz frequencies and you want to amplify them, then you cannot use RC coupled amplifier or transformer coupled amplifier. So to amplify the signals who are very less in frequency, that is less than 10 hertz or 20 hertz, then you will require an amplifier which will be amplifying the low frequency signals. Here the direct coupled amplifier does the job for you to amplify the low frequency signal less than 10 hertz. Why? Because here we do not use any isolating coupling devices, that is transformer or capacitor, which will offer a high reactance to the low frequencies. So here we are not using any of these kind of devices. So that is why this direct coupled amplifier will give excellent output for, or excellent gain, very good gain for your low frequency signals. Why? Because we are not using any capacitors or transformers that will offer very high reactance to the low frequency signals. So this is the main reason direct coupled amplifier is used for amplification of low frequency signals, that is less than 10 hertz or you can say 20 hertz at max. and its frequency response is also in that range. It is like a low pass filter. The frequency response is like a low pass filter. It will pass low frequencies and it will stop, or it will not amplify high frequencies. So here this is a 3-stage direct coupled amplifier. You can design 2-stage direct coupled amplifier also. 3 transistors are used, 2 NPN and 1 PNP transistor is used. So here you will get the output, amplified output for low frequency signal. So where will you get the frequencies less than 10 Hz? So when you use photoelectric current or thermocouple current, you will be getting a frequency less than 10 Hz. So to amplify those signals, you will need a direct coupled amplifier. So we'll see the frequency response of direct coupled amplifier. As you can see, the frequency response is similar to the low pass filter. See, it is passing the frequencies starting from 0 to some cutoff frequency fH, and after that the gain is reduced over above the cutoff frequency. You can say the gain is constant for low frequencies, and for higher frequencies gain is reducing. So from this frequency response you can say that the direct coupled amplifier is very good at amplifying low frequency signals, and whenever the frequency increases, the voltage gain reduces, and as the voltage gain reduces means what? You will not get a amplified output voltage of the input signal. So you will get amplified output voltage in the frequency range of this only, 0 to fH, at the low frequencies only, because it will be providing a providing a constant voltage gain over this range of frequencies. So we'll discuss why this gain falls below the cutoff frequency or at higher frequency. So see, as the frequency changes, or you can say when you are not using any coupling device such as capacitor or transformer, the DC biasing of the circuit will vary according to the frequency. So as you all know, when the DC bias or Q point is shifted in accordance with the signal frequency, the higher the frequency, the higher the variation in the Q point, and because DC biasing conditions are changed slightly, there will be a temperature variation in the transistors of this circuit. So the variation in temperature will cause a shift or change in your Q point. As your Q point will get shifted, you will not get your desired amplified output. I already explained that the importance of Q point in your amplification process. So to amplify the signal, your Q point must remain in the center of your load line. So due to temperature variation, if your Q point gets shifted, then you will not get a very good amplification. That is why at the higher frequencies you will get very low output, and in the lower frequencies you can get the good output. So this is all for now. This is the very basic explanation regarding direct coupled amplifier. In the next lecture we'll see another different type of amplifier. So thank you for watching this video.